Today is a beautiful day for science. This solar flare here is it's quite beautiful. We're actually seeing how a solar flare occurs very nicely by the way that this is lined up with the camera view. You can see that these loops coming across this way have crossed, and this is the high microwave frequency that's occurring due to this. And this material above is it's the loops that are reacting to losing their connection with the lower end loops. So these right here, this is your material that gets sent outward due to what's happening here at this X point, the cross. And then the large flare, the significance happens when the material and energy gets slammed from this lower end downward and causes the most significant shortest waves of energy to be released outward. And all of this up here, depending on the amount of energy that caused this event or is released from this event, becomes the coronal mass ejection or solar rain, plasma rain, or just it just falls back down to the sun in general right at that location. So we don't know if it's a CME just yet. Most likely will be, but we will see. In looking at angstrom 16 or 1600 angstroms rather, you can see that a lot of the plasma at a cooler temperature is being displaced and it's going upward. This is quite a distance into the corona that it's going. And I think it's quite suggesting that some of this did in fact become a CME, coronal mass ejection, but that doesn't mean that it's going to go outward and hit anything beyond that, they have a specific term for those that hit other planets, and it's just simply interplanetary coronal mass ejection, the ICME. So if you hear me mention that, that's why. But this right here, I would say, is an active CME currently, and I would say it probably has the potential to be an ICME. But more notably is how beautiful we can see this cooler plasma displacement from this side angle that we can't typically see when we're looking straight on towards it. And looking angstrom, 94 angstroms, which is very, very short. That's 9.4 millimeters. Or, yeah. There we go. So, looking at the more sensitive 94 angstroms, the nanometers, there we go. We can see that the spread of this energy, this heat, has encompassed a lot of the loop's locations in the lower end, and even so much so as that it's pushing outward, causing it's kind of like a splash. It looks. Now this is the same region that gave us a couple of southward CMEs while facing us and before coming around to us. And while it's been quiet for the past, well, relatively quiet for the past few days, it still has been part of several material that's been building up. So seeing this become a coronal mass ejection that we're seeing from this event is not a surprise. Looking at angstrom 131, and 131 angstroms is really helpful and beneficial because it shows us the more significant pinpointed areas of where the heat's at. So the wider points is the most significant heat registered. And this right here is showing us that, once again, as I was saying earlier, the shortest waves are going to be closer to the surface, as we see here. So we had the microwave and then the outer waves going on through the event, and then as we get closer to the surface with the flare, then it's the hottest points, as it were. And well, this just reflects that very nicely. So angstrom 94, or 94 angstroms, 9.4 nanometers. I don't know why I keep saying millimeters. It shows us a good, quick view of where the solar activity is occurring. But 131 angstroms, which is 13.1 nanometers, it shows us approximately where the hottest points of that flare is occurring. So that's why you'll see me go to the green sun, which is SDL's green sun, 94 angstroms, and the light blue, which is 131 angstroms, and to see where the flaring activity is at typically. This is my go-to, and if I can't see it distinctly there, or if there's multiples, I sometimes refer to 1600 angstroms, which shows us the pale green sun imagery and helps us to see where you'll see like a lightning strike, almost kind of thing. And that flash is typically where it flares at when facing towards us. We can see it very clearly, but we don't see that displacement that we see from the side-on view. that we saw very nicely. Now looking at angstrom 171 or 171 angstroms, this is the best at looking at the coronal loops. And again, we're seeing that this is still ongoing. Now these photographs are about 10 minutes to 20 minutes behind what we see on the flux. So keeping that in mind, about 10 to 20 minutes ago, this one exactly is at, what time is it UTC exactly? I'm going to hide the sun for a second. Okay, so this is about 10 minutes ago, I think. It's hard to see, it's really small. I'm using really high resolution images, so it makes it a little harder to see some of these, unless I blow it up too much. But anyways, you have you can see the crossing of some of these loops here. You can see how this activity is still ongoing. It's not as simple as there was a flare and two loops collided or multiple loops collided and done. This is a very prolonged activity, and especially to the fact where all of these are light waves. All of these are giving out frequencies, radio waves. And as that happens, it's constantly giving us some kind of signal that's quite beautiful to watch. And in fact, looking at the EOVSA solar dynamic spectrum, there it is. We can see, it'll update here shortly, but right now it's still, yeah, we should start seeing it soon. But anyways, yeah, so it shows us the frequencies that it's registering, and you'll see that it's not just as simple as at a certain peak, and that's the frequency. It's a broad spectrum of frequencies. Yeah, so yeah, I expect that once this updates, the frequency display here will show very nicely how that increases in the displaying what the flare activity was. And this is viewing from on Earth. So this is all the frequencies that are making it onto Earth through the atmosphere. Just imagine if we didn't have the magnetosphere protecting us from certain frequencies and whatnot and different light waves, we would basically burn up. Well, not basically, we would burn up. Yeah, see if we can get, no, they haven't updated yet, so that'll be a little bit. We'll look at that once that's updated. Now looking at 193 angstroms, this is the bronze sun, as some refer to, and where's that? All right. Anyways, yeah. So you can see here once again some of the loop activity. So this focuses more on looking at the corona, and what's good for this, especially, is it shows you the deeper coronal holes, which are the darker spots. In this, though, where it gets really hot and it definitely illuminates pardon me, behind the coronal loops very nicely, we can see the structures that's actually impacting here. And we can see some of the flashing still occurring at the midpoint. Where's my little pointer guy? There you are. Hello. There he is. And you can see how, there's the little flashing points here. And you can see how the reconfiguration isn't just a really quick process. We can see the spreading out of these loops as they are displaced, no longer connecting towards the areas they were. And as that occurs, it's going to, as it expands and moves outward from the sun's surface through the corona and then outward beyond there, it expands so tremendously that these CMEs can encompass 31 million miles in every direction diameter. So that's, about 15.5 million miles in each direction from its central point approximately. So that's quite a spread, and that's why a CME, even though it's we're getting hit by a CME, say for instance, it's barely any of it is even impacting us. It's a very minuscule amount. So just imagine how much energy is in this point right here that hasn't even barely started to spread. And looking at angstrom 211, and 211 angstroms is really beautiful to show us where corona holes are entirely. So it doesn't necessarily show us the strongest corona holes, which corona holes, by the way, are not really holes in the sun. Think of the corona as like the sky for Earth. We have a sky, the sun has a corona. And when there's a corona hole, it means it has clear skies at that point. And typically, that means there's going to be a lot of faster moving, cooler plasma. And that's where we get our solar wind from, those solar particles. And looking at 211 angstroms, it shows us, once again, much like in 193, but less detail of the loops itself, more of the corona focus. And you can see how the spreading has gotten to the point where it's still showing quite detailed on 211 angstroms. Now, most of these filters that are used focus on iron, but 304 angstroms, which is one of my favorites, and the basis that it focuses on something entirely different and is extremely important because 304 angstroms, focusing on singly ionized helium, tells us where the corona mass ejection is essentially occurring. We can follow that plasma, and as you can see, massive amounts of plasma is in motion right now. Very, very hot, and it's expanding. This could very well turn into a beautiful side view CME that I'll probably make a video of. The updated 94 angstroms coming up here. It will show us the expansion of that heat that's occurring. Once again, this shows that lower end heat for the solar flare activity. So even sometimes when it looks like it's a flare occurring, that's not necessarily always a flare. It could just be very hot plasma. In this case, it is a flare. And we can see that hotter plasma from this flare event has expanded even a little more. And you can see a lot of it at the surface point. But more so looking at angstrom 131, we can see how the hotter point's still near the surface and can see the loop activity and the reconfigurations causing a lot of heat in the corona area as well. Back to 171 angstroms, newest image. We can see a lot of that microwave frequency has already gone with its downward push, and it's going to be condensed and slammed to the surface, giving its shortest wave frequency for those. The more significant point has the more significant point of the flare has occurred, and we're seeing the essentially like a follow-up. And once again, remember these images are 10 to 20 minutes after the flux has already shown us. So we're looking at what has happened just recently, and we're watching and looking at it just as quickly as the scientists. So it makes this a very fun experience that we are on the edge of our seats just as the scientists are watching this. And one of the things to keep in mind with the coronal loops is they are a helix of magnetic field lines, and you'll see the spiraling that's caused by that. And they're spiraled because the center of the sun rotates faster than the northern and southern portions at a ratio that slows as you go further north and further south from the equator. And due to that, it causes the magnetic field lines to form a helix from that spinning around, that winding it. And it traps inside of it the plasma. Now, the magnetic field lines also contain their own polarity, and then the plasma in the middle also contains its own polarity, so you end up with three directions when we have a CME. So you have your spiral, and just like a spring, you see it goes up on one side, down on another, and just keeps coiling. And you have your center point, which has its polarity going south to north, north to south, or west to east, east to west, depending on its orientation. So because of that, that unique formation, we can see a lot of times in these solar events that there's a spiraling motion that occurs in the flare. And you'll see that there's a helix from the viewpoints of the coronal mass ejections as they depart from the corona into space, as they expand, maintaining that formation. And that's exactly what we're seeing here. And if you look closely at this 171 angstroms, you can see that there's a nice little spiral, the hotter plasma in the middle, enlightening the whole thing, and magnetic field lines hide that illumination. You don't get as much luminescence from a magnetic field line. And that's why, in fact, when you're looking at the sun, you see a sunspot, that the umbra is really dark. It's because it's blocking all of the light from the sun. It's blocking that. It's becoming an occulting disk, as it were, from all the plasma. So it's not viewable through the umbra. But it still contains all that energy, and we can see it. Yeah, I could probably zoom in more. And at this point, we're starting to lose a little bit of the definition, so this is about as far as I can go without having to do some more enhancement. But yeah, you can see how there's some of that spiraling occurring here, a little bit of a helix motion there. And you can see how the plasma showing through isn't just a straight line of plasma heat, except for where it's widening out completely from that magnetic field line. You can see it's like lighter, darker, lighter, darker, lighter, darker, and that's because that plasma is within that magnetic field line. quick look at the updated angstrom, 304 angstroms, and we can see more clearly what I was discussing about that darker point being the magnetic field lines. These are here in front of the plasma that's sort of seeping out where it can and showing between the curling helix that's holding the plasma within the magnetic field lines. You can see how this spiraling event has a helix motion that's wrapping around itself like a coil. And you can see how the inner portions where the plasma has been released is coming downwards to the sun and is the hotter points. This is plasma that has escaped or barely contained by those magnetic field lines anymore, so it shows a lot hotter. Now I have this image blown up. If we were to look at the whole sun, it would be a little over 32K resolution. So can't really make it enhanced any more than this without losing some of the details. Most recent 94 angstroms. And looking at this, it looks like we might be seeing some activity on one of our northern regions just starting. Let's look at angstrom 131 angstroms to be sure. No, it's just a hotter point. I don't see any activity actually happening there. However, we do still see some hotter flaring and hotter plasma points here. This is extremely hot. Let's pull up the details exactly. So right here we go. 18 million degrees Fahrenheit, 10 million Kelvin. So as you can see here, this is quite a significant amount of heat. And this is what makes a star so unique. It has that compression of this energy, all those molecules creating it, creating light. And keep in mind, Jupiter is a feldstar. It doesn't have the density and compression to ignite itself. So it's an interesting little tidbit. Looking at the latest 171 angstroms, and we can see the continuation, that crossing, those helix formations of the magnetic field lines. You can see how it's on spiraling to some extent, but maintains a helix form still. And a lot of broken loops here, a lot of loops that are displaced. It'll be interesting to see how they play out. Yeah, while Jupiter is a failed star, it has actually become the big brother of Earth. A lot of projectiles, asteroids, and debris that would have a heightened chance of hitting Earth has been pulled into the gravity of Jupiter, and as such has protected Earth from many significant possible catastrophic events. So, yeah, Jupiter is like our big brother. Especially considering we would have a star on either side at that point, to which, of course, gravity would be completely different in how we experience it if we could survive the heat of two suns with that proximity. In all, some very fantastic solar activity. Even though it's not an M class or an X class, from a side-on view, it gives us so much more detail of what all is occurring. So even a C class is extremely fascinating with that detail. When looking on them straightforward, a lot, this activity is still happening. We just don't get to see it as well, detailed as well. And this is why I still believe that we should have a far more interest investment into maybe getting like a, instead of just stereo ahead and behind, two stereo satellites, we should have like six or eight, and get a good view of every angle of the sun, as it were, so to speak, and be able to calculate and measure and understand this in a much greater detail and depth than we currently do. Granted, things like the Parker Solar Probe and so forth help immensely, and we've barely touched that data, from my understanding. I'm looking forward to more of that information to come public, but currently, yeah, that I don't think that's even near enough. And here we are. I love this. So, looking at the coronal loop, those loops that have been displaced, that have lost their footing as they continue with their spiraling and displacement, we can see on 304 angstroms very beautifully that helix formation that I was talking about, and the expansion that happens as it gets further away from the surface of the sun. So we have a lot of material. You can tell the darker lines where the coronal magnetic field lines are blocking the luminescence of the plasma, the radiance, and then you can see, or luminescence, not luminescence, oh, same difference. Anyways, yeah, so the yeah, beautiful helix formation, beautiful spiral, and yeah, it looks almost like a newborn plant. It's got its roots down here. It's got a little leaf reaching out. It's growing, and it's got a new leaf that's just formed right here. Yeah, it's a little harder to see in here in 335 angstroms, the detail in particular, but more specifically, I wanted to point out at this filter, you can see this darkened area, these lines, that they're the points where magnetic field lines are covering the plasma quite successfully. And it's almost like a little vein, as it were, that's holding the plasma together. Well, the flares, when they cross, it's caused by first to look at a flare. First, you need to know that it comes from activity where there's a crossing of energy that causes a spark on the sun. So, like having two live wires, or it could even happen at the surface itself during the development of a region. So you have these magnetic field lines that are carrying plasma, and as they get too close to one another, they end up causing a reaction called the flare. And at that central point, you get this microwave frequency, and as it's being reconfigured and reforming its new loop, the old loop, the above it, gets displaced. It loses its footing to the ground. So as such, the energy, dependent upon how much energy there is, causes it to move outward. And how far it moves, that's the relation to the energy that's been caused the displacement. And as it moves outward, the density, the gravity pulling the sun particles inward lessens. It decreases. There's not as much pull the further it gets away. So you end up with those frequencies diminishing. So it becomes lower and lower, and that's where you get the plasma that comes outward. However, the material that comes downward, it gets compressed and pushed closer together and slams onto the surface of the sun with a hotter and higher frequency, shorter waves. And that's why you see when a flare occurs, the brighter flash or the shorter frequency waves, shorter waves, are at the surface of the sun, while the material that's going outward is lower frequencies with longer waves. So when we have a solar flare, it's emitting light, energy, and it impacts the Earth as quickly as we see it, traveling at the speed of light. But a coronal mass ejection, that takes typically 2 to 5 days to travel from the sun, the 93 million miles approximately, to Earth. And that material, it's more mass. It's more of it's more mass. It's got all that particle plasma in it, and as it goes through space, it expands and expands and expands, and eventually it interacts with anything it runs into. The magnetic field of the sun. The sun's magnetic field, its orientation, is a constant flux. It's constantly moving. Everything on the sun is charged. Everything is a charged energy. It's plasma. And because of that, it doesn't have a fixed place of its magnetic field, its polarity. And every 11 years approximately, it swaps its north and south poles. much in due to the reason of why we get these solar flares. The center of the sun rotates approximately 25 days, while the north and southmost points rotate every 34 days, causing the magnetic field lines to cross. The Earth's magnetic field, it's not really weakened. That's a misconception of how the Earth's magnetic field works. The magnetic field of the Earth also is a constant flux for a different reason. It has a magnetic core, well, actually, metal core, that interacts with the magnetic material that comes from the sun. So we ended up having a magnetosphere form on the Earth due to the metal within the Earth and the fact that it's creating a connection, a conduit, as it were, where the north and south pole of the Earth complete that circuitry of the material that's on the Earth. So it's like having a tennis ball and putting metal inside the tennis ball in different points, and then putting an electric current on the outer points, and you'll see that that metal inside the tennis ball can complete the circuit, even though the whole tennis ball itself is not metal. Now, part of the issue is it's never stationary. The core is molten. It's not a solid core, and that's a good thing because that keeps that constantly going, that connection constantly going, and rotating and altering. And the Earth itself does have a swap where the north and south do cross as well eventually. We have our polarity swap as well. Yeah, a lot of people are taking the partial information and misrepresenting it. Basically, the Earth's core being metal and being conductive, with metal that goes through the. You can go, buddy. My pup's wanting to go somewhere. Wanting to. It constantly changes. So because of that, sorry, I lost my train of thought. My pup's he's super excited. He's getting a treat. Yes. All right, I remember now. So the energy from the Earth, the carrying the current that comes from the magnetosphere, completing the circuit of the energy from that. That's part of the problem. I need to pull up that image, and that would make things much easier. Sorry, I'm partially distracted. All right, here we go. This image right here shows exactly what I'm trying to say. So we have the Earth, and in the center of the Earth is metal. It's conductive, and throughout, going outward, there's conductive metal still. That's in liquid form, that's constantly in motion, and kind of causes a continuation of the morphing and the way that the magnetic energy of the sun, or the Earth rather, forms. So we don't have stationary poles. We don't have, and even if you got rid of the geomagnetic dipole of the north and south, it's okay, little buddy. Even if we get rid of the geomagnetic dipole of the north and the south, we have so many other different poles in the Earth. It's more complex than that. And that is what's being overlooked when people are talking about the anomaly, which has, as far as records go and science sees, has always been there, but not always been in the same place. And this is due to the motion of the metal within the Earth. That's my little buddy Loki. He's my 90-pound lapdog. Indeed. So when people talk about how the polarity of the Earth is changing and it's getting faster, it's not because something major is happening, as it were. It's a continuation of a process that has always been. And additionally, the information they're pulling from, the data they're pulling from, is all from the exact same uh, the exact same source. They're all pulling from NOAA's and now more currently ESA's data. So how they interpret that data is on them, but the data source is still the same. And that's where I think it's kind of humorous that these people have such different interpretations of the exact same data, and yet they're still reading. It's like reading the same book and saying, well, I think it means this. I find it kind of just humorous in general. All right, looking at the latest Angstrom 171, the newest one came out. I don't want to miss it because we're seeing here this displacement of magnetic field lines. They're actually more outreaching. You can see the more independent lines that are unspiraling and how they're not just a single line as well. And you can see how they interact with the other lines nearby, how they're trying to get away from it. And there's space between them even though they are coiled. So they're uncoiling and separating from one another, but still maintaining a helix form in itself. Absolutely, and if I caused any questions out of that, you're always welcome to ask. Science to me is the discovery of truth. It's a tool. It's not a religion. So as such, I don't hold to it as it's set in stone. It's based upon the continued increase of data that we get and growing and advancing it to the point where we learn more. I don't think this is going to be a complete solar hug this time, Deep Quake. I think uh, this is going to be a beautiful CME from this one, from what I can see. And as you can see, we're looking at this in relative real time. So you can see these events aren't just there's a flare and it's done. It's a prolonged event of continuation. You can see looking closer to the surface, these hotter points, these loops here. These are the new loops that displaced these bigger ones. And that's because it found a shorter point of connection that no longer needed to transfer that energy all the way to one other point. It's the point of least resistance, as it were. No, absolutely. Science in school was abysmal, in my opinion. I wanted to advance furthermore into the science field and things of that nature, and I was sort of put off it by the way it was presented at school. They presented it in such a way it was closed-minded, as it were, and it's even worse now, where science is portrayed in a point where it's more chaotic and closed-minded when it's actually very defined yet open-minded. There's so much to discover. There's so much still to do. We've barely touched the surface in so many areas, including knowing the very Earth we're on. I just found out recently in a study that you can fit the entire world's population into the state of Texas in the United States. And they could live comfortably in a city. Well, that was the whole thing. It had to be a city. So imagine a city like New York City. That's what they used as their example. New York City, the size of Texas, would comfortably hold everybody in the world. I think that's so bizarre thinking about it. Then again, you'd have to think about how comfortable that would be for everybody. My particular tastes, I like having the space. So I'm not in a very thick cluster, as it were. I enjoy it, the less clustered. looking at angstrom, 193 angstroms once again, you can see that coil becoming more defined. You can see how this is actually a helix formation, spiraling, encasing the plasma within. And you can tell a little more clearly now. As it's reached further out, it's got more expansion. You can see these loops having more definition as well as their formation showing nicely, their interaction with one another as they continue to try to find their new placement, having been replaced from this surface area that's all really hot now. Keep in mind, remember these images, because whenever you see a flare that's towards us, this is still happening. We just can't see it in such great detail. This is the beauty of this occurring on the side as opposed to towards us. And of course, when it happens towards us and we can see the definition that way, we get a whole different set of data that's more pertaining and informative. That's just well-rounded in a different facet. For instance, this event, looking at this from the side, we can't see how broad it is. When looking at it from head on, we can see its entire encompassment of north, south, west, east. This data is in real time. We're seeing it as quickly as the scientists are, so I don't know how that would be hidden. In fact, these images are coming off the actual satellite database itself that I have access to. So we're seeing it as quickly as they are. I don't see how that can be hidden. Oh, here we are. 304 angstroms. Now we're starting to see the complete displacement. We got a plasma displacement, magnetic field lines going across, and this is going outward. It looks like it's like someone that's got their arms outstretched upwards and flying upward. I like to see shapes in the CMEs. I apologize. It's a fun thing. Where is this nine? I am not seeing any of that. I've been following this for a while now, and I have not seen any signs of hidden information from the science data that I've been pulling. This channel stays up 24/7, best I can, and I have not seen any sign of hidden information. As for time travel, I think that there's too much that we do not know to just flat out say something's not possible. We see time as a linear thing, but that doesn't mean that it is, because we also see that time can be, or it's a theory anyways, time can be changed through gravity, that it reacts differently in gravity. Interstellar is a movie that comes to mind that approaches that theory to some extent. And I mean, who am I to say that that's not correct? I don't know. So as such, I think it's a very well possible, but no way to say either or. Yeah, time travel is just a very. I'm a big Doctor Who fan as well, so that Tom Baker and John Pertwee. So yeah, the whole concept of time travel is very fascinating, and hopefully one day we have a better understanding of it. For or against, just learning is a great thing in general, and the more we understand the facts, the better it gets to learn the next thing. As long as we don't adhere to untruths, the things that aren't true or whatever, then we can continue to expand and learn more and enjoy life in a better facet, in my opinion. Cosmic blast? I know that we get cosmic radiation or cosmic particles rather, uh, that do cause neutrinos and other things of that nature. But solar activity is actually a great thing due to that because it actually creates like we have the magnetosphere on Earth. The sun creates a bubble just like that. It's not necessarily a bubble, it's just an expression, as it were, because it has multiple layers and it takes the energy that interferes or collides with this layers, these multiple layers, and displaces it like a shield. And it basically prevents all of that cosmic radiation or particles from impacting from the inside, anything inside. So it's awesome. Now, the relation is gravity and density, that density and gravity is tied. And somehow that can manipulate time as well. So, like I said, I don't fully know the theories behind it. I just find it very fascinating. But I try to focus on one thing at a time. And my current is all the data about the sun, which is more than a single person can do in her lifetime, in my opinion. There's so much data. And I also look at volcanoes and earthquakes and things of that nature. The latest 171 angstroms just came out. Let's take a look as these magnetic field lines continue to find their new place in so forth. And so much more, we're seeing these outward disbursement where it is not only spreading out, which of course would be not possible closer to the surface, but it is also taking an interesting form. I just love the bridging area where you can see this, where these loops used to cross, and now they're, instead of going downward, that's a lot of energy pushing these loops upward here. And you can see that it's happening faster to these little ends than it is in the center, which basically shows where a lot of that energy release propelled these magnetic field lines from the footing. No, this is not a relatively large sunspot. It's one that's rotating off the Earth-facing disk, which is part of the sun that's facing the Earth. Uh, and we sometimes, from these regions, get a nice event that occurs just as it's rotating away. It takes days to completely rotate out of view. So, a lot of times it appears that there's a lot of activity happening only at the edge, but I mean, if you look at it statistically, though I hate statistics in general because it's the art of measuring something enough times to get the answer you want. Anyways, so statistically, uh, it's expected you'll see more activity on the edges of the sun than you would facing you. However, though, seeing this kind of activity here is just to me one of uh, the great examples of how we don't know enough of our sun, in my opinion. Jupiter is much further away from the sun than Earth is. Earth is the third planet, third rock from the sun, as it were. I don't. I don't put my confidence into comic book science. It's interesting, but I used to read a lot of comics when I was younger. Big fan of the. I liked the Fantastic Four, but that wasn't my thing. I was more into the X-Men. In fact, Doctor Who had a short series extent with Marvel Comics in the '80s with Tom Baker, and I thought that was pretty cool. Salutations to Arizona. Yeah, so like a rubber band, you're holding a rubber band, and it's got footing that's holding these loops. You know, the rubber band's feet are holding to the ground. And if you were able to clip those footings, you know, you clip one on each side, you know, rubber band starts to fly off. You see the ends go forward first, and the top follow behind. And that's what we're seeing right here. We're seeing that footing of these loops catching up to this upper area of these of the upper portions of the loops. I don't think I explained that well, but yeah, I'm just enjoying the imagery. It's quite beautiful watching how a solar event, a solar flare, and the CME that occurs sometimes in conjunction to these, how it plays out. Yeah, I'm definitely going to have to make a video of this event. This is beautiful, and it's relatively small too. I mean, it's I've got this zoomed in quite extensively. We're looking at approximately a 32, a little more bigger than a 32K resolution image. So if I were to show you the dimension of what this really is, it's actually very small. Let's go ahead and do that real quick. So yeah, it's just that little edge right there. It's a very, very small event. And additionally, I'd like to point out this is nowhere near an event that looks like it's going to um, project towards Earth. So I do not believe we're going to be hit by anything other than, of course, the flare that did occur and travels at the speed of light. So within 8 minutes of it occurring, we are seeing that flare. And but the CME, that if there's one that is going to associate, and I do believe we will see one from this event, if there's going to be a CME, I don't see how we're anywhere projected. So I don't want anyone to get worried. There's no CMEs that are coming towards us from this event. Well, can't guarantee it. I'd say 99% sure. The beautiful thing about science is there are no absolutes. We have to leave the room or the space for possibilities of things that might happen. And currently, there is also a very small event happening in the northern region. Indeed, this is a very small event, but I like to get an up and close view of these events as they occur. So I try to enhance the images best I can through the training I've had for what I did when I was in the military, and by doing that, I can sometimes double to even 4 times the resolution of an image, uh, so that I can get better detail out of it. As such, I typically get to see the small CMEs and small flares that occur. And that's why I was saying that it's not possible for scientists to. I was thinking a box with a ribbon. But it's not possible for this data to be hidden, as it were. And I don't understand that thought process, because we can see the very minuscule amount of detail, or down to the minuscule details, in the same time that the scientists are looking at it themselves. So I think it's a wonderful thing, and it's something that I don't